Okay, hi all. So now we start with the new chapter, which is chapter 4. So I would say that chapter 4 is nothing to do with the chapter 1 to 3, but all the knowledge, even though I'm saying that it is nothing to do with the previous function that you have learned, but the way, the idea, the concept will be the same in because in chapter 4 you will deal with a new type of function where we call that as a vector function. So what is the thing that you will focus? You will be focusing here. You will learn how to sketch the graph, how to differentiate and integrate that particular functions, and what is the application that can we relate with the vector function. So you can evaluate the velocity, the acceleration, and also you can obtain the unit tangent vector, unit normal vector. Okay, for your information, in 4.4 this one is omitted. Okay, so because the note that I shared with you, I provide you the for the specific numbering, so I'm afraid that you're confused with the numbering is not following the sequence. So for information, the part 4 is omitted. Okay, so then we continue with the motion in space, and after that we learn more about the scalar and vector field, which is about the curl and divergence, and also the application of differentiation of vector function is direct to get the directional derivatives. Here, what is a vector calculus? So the two words is combined, the vector and the calculus. So as we know that the calculus is something has to do with differentiation and also integration. But now we have the word of vector. So as we know that vector, what is the special property of vector? So as we know that vector has not only the magnitude, but also it has the direction. Okay, so now we want to combine the idea of the vector, which is we have a function, but it is described in vector form. So then in order for us to apply in the real life problem, so we can also not just a regular function, just for example y equal to x squared. So for the vector function as well, we can differentiate and also integrate them, and then we can apply that the vector calculus in real life problem. Okay, so what is the problem, the real life example that we can have? So the vector calculus can be implemented in order to get the velocity, momentum, force, electromagnetic field, weight. Okay, so another application is we can obtain the force, torque, and velocity, and we can implement the vector calculus in military usage, projectile problem, in gaming problem, and also for designing roller coaster, and also we can implement the vector calculus in boat crossing a river. And actually there are very many applications that can be we can apply the vector calculus. Okay. Okay, so now what is inside the actually we have chapter 1. Okay, because I also need to teach the engineering maths too, so we also have this particular topic, so that this chapter, this vector calculus is in chapter 4 for that particular subject. So but the content is just not all the same, but I use the same material as for the engineering maths 2 subject. Okay, but there are some other thing that you have to focus in chapter 4, I mean chapter for this chapter. Okay, so vector calculus. So actually the topic is, I mean, because of the title of the course is vector calculus, so I would say that half of the content, I would say that all of the 100% of the content has to do with the vector function. Okay, so firstly we want to know okay, I want to introduce you the vector function, and then how can we sketch the graph of the vector function, and then we can, after that, we start to figure out the application of the vector function. For example, you can obtain the unit tangent, unit normal of the vector function, and also we have the we can apply the vector function in motion in space in order to get the velocity and also acceleration, and you have many application later on. Okay, so this one some review. I don't think I will explain in detail for this because I'm sure that you have learned this, but maybe you have forgotten. So it is good for you to read yourself, and if you don't remember, then you just go googling and then review yourself. I mean, make some revision on the vector, something related to vector. Okay, maybe you have forgotten what is the position vector and displacement vector. So what is position vector? Okay, I have a quick question here. What is the position vector? Okay, position vector means something to do with position, which has to do with a point. Okay, if you sketch the graph on 2D, y, x, so you are passing through, so that is your path. Okay, so you this is you, and you just walk around, and this is your starting point, and this is your end point. Okay, so normally vector function has a parameter. Okay, so I would say that the common parameter which lies in the vector function is t, which is time. Okay, so now, so here, that this is your starting point, right? So that one is when t equal to 0, your initial point. So let's say your initial point is at point of oh sorry, your initial point is at the point of 1, negative, yeah, -1, -4. Okay, and then here is the t when the time is 10. The time here can be second, can be hours, so just we just ignore the unit. Okay, so maybe at the when t is equal to 10, at t equal to 10, so your point is at it should be higher, right? 5. This one supposedly not -4 but 4, so 5, maybe 6. Okay, so that is point. Okay, so the position vector mean, okay, let's say I'm taking your position, your position when t equal to 0. So where are you now? So you want to represent the point in terms of vector function, or vector in terms of vector. So you have to draw a straight line. Must be straight line. You have to use a ruler. Okay, and then that line is passing through the origin and also that point. So then, because we know that the vector has a direction, so point to that point. Okay, this arrow point to this point of -1, 4. So now let's say I put r. The r is the vector, is the position vector when t equal to 0 is given by negative 1i plus 4g. And so this is point minus 1, 4. But when you want to represent into a vector form, so we call this as a position vector. The vector that tells you where is your position now for specific t. So that is a position vector, for those who have forgotten. And displacement vector is if you move from this point to this point, and the displacement vector is the difference between the component x and the component y. So that is a displacement vector. Okay, so that is very basic. If you don't remember, just go googling. I'm sure that there are very many references out there. And what else that you have to know? Component form. Okay, so this is also very basic. And then vector form of line. Okay, let's see here. You are given an information. There are two information given. A point. Okay, you are given a point where the point is located at 1, 2, 3. Okay, at the point of 1, x equal to 1, y equal to 2, and z equal to 3. Okay, so this is a point. Okay, and then you want to obtain the vector function of this line. So can we obtain the vector function? Of course you can, but with the condition there are two information that you must have. First is the point. Okay, the point which the line is passing through, and also you must have the parallel vector to that line, to this line. So in this case, let's say the parallel vector to this line is given. So this is in terms of vector form. Okay, so then the vector form is given by 4, 5, 6. Okay, and be careful to make a difference between point and vector. So you have to be careful with the bracket that you are using. So for the point, because this one is a point, right? So the point 1 to 3 is a point, so you have to use the open bracket like this. But this one is a square bracket. Okay, square bracket. Square bracket. No, this is not square bracket, but the bracket a bit something like that. Okay, square bracket is this one, right? So that is not square bracket, but this kind of bracket. So if you have this bracket, so this tells you that you have a vector. So the vector of this line, where this line is parallel to the line of the vector function that we are looking for, is given 4, 5, 6. So what is the formula that you have to use in order for you to obtain the vector function of this line? So you want to get this particular the vector function of this. So RT is a vector function. So the vector function of this line. So the formula is given this one. Okay, RT is the vector function that we want to obtain the vector function of the line. This one is applicable only for line. Okay, whether the line the straight line. Okay, so the formula is R0 plus TV. Okay, T is a parameter. In vector function, there is a parameter T, where you have the vector function in terms of T, and normally T is a time. But it depends, okay? Not always the T is a time. Okay, but then what is R0? What is a V? So the bold one, you can see something bolded here, right? So the bold one are representing vectors. So R0 is a vector. What is R0? R0 is a position vector. Okay, so this one is position vector. How can you obtain the position vector? Position meaning that you are given a point. Okay, a point must be lying along or passing through the line that you are looking for the vector function. You cannot use the point outside the line, so that is impossible. Okay, must be a point lying along the line that you are looking for the vector function. Okay, so R naught. So then here you have the point. You have the point 1, 2, 3, a point. And then how can you obtain the position vector? So the position vector, when this is not equal to 0, but just in this case, R naught means representing position vector. So the R naught, okay, the R naught is, now you just convert to this kind of bracket. Sorry, I don't remember what the name of this particular bracket. I will figure out later. Okay, so from a point, you can change into a vector just using the different brackets. So you just put 1, 2, 3. So now you know that this is called position vector. Then you have to put here. T is T multiplied by the vector V. So what is a vector V? So vector V is the vector function of the line which is parallel to the line that we are looking for. Okay, so you must have these two information, the point and also the vector which is parallel to the line that we are looking for. Okay, so then we substitute. So here R naught is 1, 2, 3 plus T and multiplied by the vector V. So vector V is 1. Oh, sorry. The V here is okay. The V here is 4, 5, 6. Okay, so we have 4, 5, 6. And then because we have a summation of two vectors here and T is multiplied inside here, so then we have something like this: 1, 2, 3 plus 4T, 5T, 6T, and then because these are the summation of two vectors, so then you can write down into a component. So for component X, you have 1 plus 4T, and for component Y, you have 2 plus 5T, and for component Z, okay, you should continue. I have not enough space here, so 3 plus 6T. So that is your vector function, okay, in a vector form. There is no IJK here. I don't use the IJK. I always use this kind of bracket, easy for us. Normally, I will advise my student to use this more easier. Okay, so that is the how can you obtain the vector function for a line. Okay, and then from the vector equation or vector function, we always have the parametric equation. So what is a parametric equation? Parametric equation, remember we have a method 1 before this. So what is a parametric equation? So if you don't remember, then do some revision on it. Okay, so this one is for component X. So we have X equal to, so now I write down X equal to 1 plus 4T. And then for Y component, I have Y equal to 2 plus 5T. And for Z component, we have 3 plus 6T. So this kind of equation, okay, this kind of equation are called as parametric equation. Okay, remember, for any vector function, there must be parametric equation. Just a revision. Okay, and then some property of the vector algebra, or the addition, so multiplication, and this is very useful. You need this again for this semester. How can you obtain the unit vector? Okay, remember, all the vectors that we have, they must be, each of them, all of them must have a unit vector. Okay, for any vector that we have in the world, there they must have the unit vector. So how can you compute the unit vector? The vector itself is divided by its magnitude, where the magnitude of the unit vector is always equal to 1. So that is a special property of unit vector. Scalar product, we have this kind of dot, and vector product, we have cross product, or we call that a cross. Okay, so this also very important. You will use them again and again in this subject. And then how can you compute the cross product? By using all the components. So this is also, you need this always for this semester. Okay, so these are something that you have to revise. Okay, next we will focus on our aim is to know how can we sketch the vector function. Okay, see you on the next video.